Problem 7-117. Am I special? Shayla drew quadrilateral SHAY shown below. The coordinates of its vertices are as follows. Letter A. Shayla thinks her quadrilateral is a trapezoid. Is she correct? Be prepared to justify your answer to the class. In order to prove whether or not this shape is a trapezoid, which it looks like it may be, we would simply have to prove the definition of a trapezoid, which, as we defined in a previous lesson, a quadrilateral with one pair of parallel sides. So going back to that problem, we would just need to prove that these opposite sides here, HA and SY, are parallel. Take a moment and try and prove that those two lines are parallel. In order to prove lines are parallel, we need to find the slope. So find the slope for this line and the slope for that line if you have not done so already. If we make slope triangles for these two lines, we'll see this one has a rise of 3 and a run of 4. So m equals 3/4. This line has a run of 7 and a rise of 4. So m equals 4/7. In order for those lines to be parallel, these slopes would need to be the same. But since they're not, they are not parallel. And therefore, this is not a trapezoid, because it does not meet the definition. Opposite sides are not parallel. Does Shayla's quadrilateral look like it is one of the other kinds of special quadrilaterals? Take a moment, look over your Chapter 7 toolkit, and see. The closest thing I would guess is that it looks like a right trapezoid, but since we know it's not a trapezoid, it can't be a right trapezoid. So it really doesn't meet the criteria of any of the other quadrilaterals on our toolkit. Maybe you thought a kite, but in order to be a kite, it would have to have two pairs of congruent sides, and we can see pretty clearly that it doesn't have that. It might have one pair of congruent sides, but not two. So it looks just like a regular old quadrilateral. On to letter C. Go ahead and read through letter C, hit pause, and then play when you've done so. Okay, might this have any other special properties? Might some of the sides be congruent, and might there be right angles? So in order to do so, maybe look and see if an angle appears to be a right angle. Do you see any that might look like they could be? If you said angle A, I agree. It looks like a right angle. But in order to do so, we have to find the slope of AY. So calculate the slope of this line segment. As you can see, this has a rise of -4 because it goes down 4, and a run of 3. So the slope of this line is -4/3. Are these two opposite reciprocals? Yes, they are. So opposite reciprocal slopes means lines are perpendicular. So that is, in fact, a right angle. Now go ahead and try and find the lengths of the different sides to see if any of them are, in fact, congruent. You can use the Pythagorean theorem, or you can use the distance formula. It's pretty clear that this side isn't congruent to any of the others. But what about the other three sides? Well, we know that this side here has a length of 5 because it simply goes up 5 units on the y-axis. Well, what about this side? You can look at that right triangle and see that the legs are 3 and 4, which means this is a 3, 4, 5 Pythagorean triple. You have a leg of 3, a leg of 4, which means the hypotenuse is 5. You can do the Pythagorean theorem to prove that or to check it. Same thing here. We have a leg of 3, a leg that's 4 units long, and so that hypotenuse is also 5. So we have another Pythagorean triple of 3, 4, 5. So this shape does have some special properties. It has 3 congruent sides and it has a right angle, but it doesn't have any parallel sides, which means it is nothing more than a quadrilateral with some special properties. It's none of those on our toolkit.